Hello, welcome to another exciting series. In today's series, we would be discussing a question on substitution into formula in mathematics. Right. So let's quickly delve into it. So we have a question here which states that given the equation R equals 5.4 pq as the numerator and 6q minus 37 as the denominator, right? So R equals 5.4 pq divided by 6q minus 37, where p equals 7 times 10 exponent 7 and q equals 4.5. Calculate the value of R, leaving your answer in standard form. Let's quickly solve this. So the preamble was given, right? So the preamble was that R equals numerator 5.4 pq divided by denominator 6q minus 37, right? Where p is equal to 7 multiplying 10 exponent 7 and q equals 4.5, right? So here we are going to insert the values into the equation, okay? Right, so when we insert the value into the equation, we are going to get R equals 5.4 multiplying P, which is 7 times 10 exponent 7, multiplying 4.5, all divided by the denominator, which is 6, multiplying Q, which is 4.5. So 6 multiplying 4.5 minus 37. Right. So here we'll move on to the next step and group like terms, right? So we group like terms. Okay. So when we group like terms, you get to find out from here, from the previous step, that some numbers are in simple numeric forms and others are in standard forms, right? So 10 exponent 7 is in standard form, okay? So in standard form, the base is always 10 and the power or the exponent is the number that indicates how many times 10 is multiplied by itself, okay? So that makes this 10 exponent 7 an odd number. So when we group like 10, we are going to shift it to the other side. So here we are going to get 5.4 multiplying 7 times 4.5 multiplying 10 exponent 7, or 10 raised to the power 7, right? That's for the numerator. So the numerator is the value on top of the fraction, right? So in a fraction we have numerator and denominator, okay? So the numerator is the number on top of the fraction, or the value on top of the fraction, and the denominator is the value beneath the fraction, right? So here the numerator is 5.4 multiplying 7 times 4.5 times 10 raised to the power 7 as the numerator. So let's move on to work on the denominator. The denominator is given as 6 multiplying q minus 37, right? Where q is equal to 4.5. So in order to insert the value into the equation, we are going to get 6 multiplying 4.5 minus 37. So now we've gotten a perfect fraction, okay? So let calculate for the values. Okay, so 5.4 multiplying 7 multiplying again 4.5 would give you 170.1 as your final answer. Okay, so we are going to get R as 170.1 multiplying 10 exponent 7 all over 27 minus 37, right? So we move on to the next step, which is giving us R equals 170.1 multiplying 10 exponent 7 divided by negative 10. The negative 10, we had it as 27 minus 37 gives you negative 10, right? So this negative 10 applies to the entire fraction. So it's the entire fraction is affected by this negative 10. So it applies to the entire fraction. So we are going to get R equals negative 170.1 times 10 exponent 7 divided by 10 exponent 1, right? So as I said earlier on, right, this negative affects the entire fraction, okay? And this 10 stands on its own. Standard form, whenever a base is standing on its own, it's equal to 1, right? So it explains why 10 here is raised to the power 1, okay? And in standard form, there are rules to it, right? So in standard form, okay, whenever there is multiplication, it means addition. Okay, so that's the rule. Multiplication means addition. Okay, that's the first rule. The second rule is that division, okay, means subtraction. Division means subtraction, okay? So these are the two rules that you have to put in mind. So multiplication means addition, division means subtraction. Okay, so we would apply this rule in the subsequent steps in solving or simplifying the equation. Okay, so let's move on. So R then becomes negative 170.1 multiplying 10 exponent 7 divided by 10 raised to the power 1 or 10 exponent 1. Okay, so remember the rule, right? So the rule I said earlier on was that multiplication in standard form means addition. Division in standard form means subtraction. Okay, so let's apply it. Now we have R equals negative 170.1 multiplying 10 exponent 7 divided by 10 exponent 1. Okay, so here we have division here. So whenever you have division, there is subtraction that follows up in order to simplify the equation. So R then becomes negative 170.1 multiplying 10 exponent 7 minus 1, right? So the rule has been applied here. So R then becomes negative 170.1 multiplying 10 exponent 6, because 10 exponent 7 subtracted from 10 exponent 1 gives you 10 exponent 6. Okay, and there's another rule here that you have to keep in mind, and we would apply that rule very soon. So whenever you meet decimal point in standard form and you are moving it, whenever you move it to left, right, whenever you move it to the left, it's going to add on. It becomes an addition. It's going to add on, right? It becomes an additional value. Whenever you move it to the right side, okay, it becomes a negative value, or it's going to lose some exponent or power. Okay, so let's come here, right? So let's come here. So here, this is the decimal point here. Okay, let me highlight it for you. So this is the decimal point here, right? The decimal point here. Okay. So whenever this decimal point highlighted here in blue moves to the left side, it gains power. The exponent gains power and it adds on, right? Whenever this exponent in similar vein moves to the right side, okay, it loses power and it becomes negative. Okay, so that's one rule. So let me state the rule here so that when we apply it, you don't get lost. Whenever the decimal point in standard form moves to the left, it gains power, or its exponent becomes positive. Okay. In similar vein, whenever the decimal points in standard form moves to the right, okay, it loses power, or its exponent becomes negative. Okay, so this is a rule that you have to jot it down. So let's move on to the next step. So based on the rule, right, we want to make 170 a perfect number. Okay, that means we want 170 to stand on its own. Okay, so in order to do that, we have to move the decimal point. And based on the rule I said earlier on, right, in standard form, whenever the decimal point moves, it determines how positive or negative, how much power, okay, the exponent gains or loses. So here, in order to make 170 a perfect number, we are going to move the exponent to the left hand side to make 1 a perfect number, right? So we are going to move it to the left side, right? So in order to make 1 a perfect number, we are going to move it 2 times. 1, 2, right? So moving it 2 times before it can become a perfect number. So that means the exponent, right, would gain some additional 2 values. So Here r is going to become minus 1.701 multiplying 10 exponent 2 multiplying 10 exponent 6. Okay, then remember the previous rule, right? Whenever there is multiplication, there is addition in standard form. Okay, so in order to simplify the standard form, you are going to get r equals negative 1.701, okay, times or multiplying 10 exponent 2 plus 10 exponent 6. Okay, so the exponents are going to add on, right? So 2 plus 6 will give you 8. So our final answer here. Thank you so much for watching this video. Kindly do well to subscribe for more. Thank you. Bye.